The Viper system is based around the ability to change the grinding tool in process, allowing multiple features to be produced within one machining cycle. This leads to reduced setting and manufacturing time, and ultimately lead time and cost. Originally developed by Rolls-Royce for safety-critical components in aero engines, Viper is a 5-axis high-speed grinding machine capable of machining some of the toughest materials, including nickel-based superalloys with extraordinary cutting rates, up to 5 times the normal performance. This process is fully capable of delivering the accurate tolerances and materials properties demanded by the exact design criteria. The technology, which employs small vitrified aluminium oxide wheels, not only offers a major advance in productivity, but also significantly reduces consumable costs and lead times. Components made from this technology include aeroblades, vanes and seals, as well as IGT blades, vanes and seal arrangements. What you're watching is a combination of promotional videos from the manufacturers that are capable of using Viper. There is no cutting fluid coming out so that you can see how the process works. In a later video, you'll see what it looks like with cutting fluid added. The principle behind Viper grinding is the coolant is injected into the grinding wheel under high pressure ahead of the grind, and then centrifugal force then moves the coolant out of the wheel during the grind, cleaning the wheel and cooling the material. Comparative results of Viper are the process saves time and money. The results are very impressive. A bearing housing using the Viper process as opposed to the turning and milling reduces cycle time by 66%. The number of steps was reduced from 8 to 3, and the consumable cost was reduced by 50%. A casing that took 10 hours to mill was ground completely in only 4 hours. The cycle time of a compressor blade was cut by 50%, from 8 minutes to 4 minutes, using the Viper as opposed to conventional grinding. The consumable costs were cut by 80%, and the overall cost was cut by 50%. A turbine blade manufactured with a twist wheel creep feed grinding machine, which utilized a very large and expensive grinding wheel, requires 8 machining steps. With Viper grinding, the blade was completed in 2 steps. The process used much smaller grinding wheels that drastically reduced the cost time. See, the real key to Viper grinding is applying the coolant. It needs to be applied at the right angle, at the right temperature, at the right pressure, and at the right orientation, and this is where the secret lies. Viper grinding was initially intended as an intermittent dress grinding process. Recently, this process was extended further by utilizing a continuous dress of the grinding wheel, which is necessary for the extreme rates of stock removal. Continuous dressing is a process that was developed for creep feed grinding and resulted in a productivity enhancement of about 90%. Effectively, what the continuous dress process does is it ensures there's always sharp, abrasive cutting edges exposed during the grind. This is obviously very important because it increases the rate of removal of the stock. Continuous dressing maintains constant pressure between the dressing roll and the grinding wheel, which is adjustable to ensure the proper amount of wheel is exposed during each revolution. This process is called microprofiling, as only a micron or less of the wheel is removed with each revolution. This ensures that the fresh, sharp, abrasive crystal is always properly supported in the bonding material of the wheel. High-speed grinding is effectively where you use Viper and add it to the continuous dress process. With high-speed grinding, manufacturers are able to achieve metal removal rates of 16 cubic inches per minute in grinding alone. Obviously, there are still limitations to grinding. With the development of high-speed grinding and Viper, it's no longer the material removal rate, and now it's more the wheel access.
Let's move on to the background of the Viper grinding. The Viper grinding is one of grinding process which using a grinding machine as equipment and grinding wheel as a tooling. The function of this process is to remove the material of workpiece to be in a shape that we want with very high surface speed of a grinding wheel. Grinding is well known in all metal working operations. Viper grinding is developing from creep feed grinding process that has high depth of cut and low feed rate. which means that this process will give high material removal rate and high productivity. About the grinding wheel. The grinding wheel is composed of abrasive particles and bonding material. The grinding wheel of Viper grinding is changing from cubic boron nitride super abrasive to aluminum oxide abrasive instead. The aluminum oxide abrasive has a soft ceramic bond that enables the tool to be cut freely, avoiding excessive overheating when grinding. By developing this type of grinding process, the originator is Rolls-Royce Company with Mackinac Company and Telluric Company as partnerships. This process was developed during the 1990s.
During the early 1970s, creep feeding grinding was first developed and utilized. In creep feed grinding, the machine table feeds a workpiece in the direction of the grinding wheel rotation. While the table speed is low, the depth of cut is very high, which results in a high removal rate. There are two key attributes that emerged that would have a significant impact on the productivity of creep feed grinding, which are the cooling supply and the wheel dressing. The supply of coolant to the grinding wheel is vital in the grinding process. The coolant helps keep the workpiece and the grinding wheel cool so the material is not burnt. In addition, the coolant transfers away the swarf material, keeping it from fouling the wheel. If the wheel becomes clogged up with the substrate material, the effective cutting edges of the abrasive are dramatically reduced. Once the wheel is clogged, the part manufacturer needs to redress the wheel and expose newer, sharp abrasive crystals to re-establish the profile geometry on the grinding wheel. To optimize the creep feed grinding process, testing proved it required delivering just the right amount of coolant to the cutting zone so as not to permit the grinding wheel to hydroplane, but also allow the optimum removal of swarf and cooling. The result of this is the Viper grinding process.
Viper grinding has been applied at a number of Rolls-Royce factories, and because of this process, the Rolls-Royce Company can reduce the lead time on production of a set of high-pressure turbine blades from around 100 to 15 days.
Components made from this technology include aeroblades, vanes and seals.
So now we're going to talk about the processes that precede and succeed Viper grinding.
As turbine blades are what Viper grinding is most renowned for, we're going to firstly talk through the processes that come before and after specifically turbine blades, and then Far is going to explain the general processes that precede and succeed Viper grinding. The turbine blades are formed using investment casting into a single crystal from a nickel titanium superalloy that is both heat resistant and strong. The process that allows the single crystal to be formed is a highly guarded secret of the trade and is to do with the helical passage only allowing a single crystal through. Making the blade from a single crystal means it is exceptionally strong. Once the wax models are made, they are then X-rayed to check for any imperfections before they are covered with the investment. The next process is casting, where the nickel titanium superalloy is cast into a single crystal. After the casting, each blade is inspected individually for any imperfections before machining starts. They firstly have cooling holes drilled and then have the fir tree slot Viper grinded to a tolerance of 5 micrometers. This is where the machining processes end and the finishing process begin. The burrs arising on the edge of the turbine blades during machining are removed in the same process without having to go to a different machine. The abrasive brushes that are used to do this are made from nylon, which is impregnated with an abrasive grain, and are held in the tool magazine of the machining center, along with the cutting tools and grinding wheels. As with all the other processes, cutting fluid is applied to ensure a fantastic finish.
Next is about the preceding and succeeding process of Viper grinding. As I have mentioned, Viper grinding is one of grinding process, and grinding is material removal process. From the amount of material removed during grinding is minor, grinding can be considered as a finishing process. Therefore, the preceding process of Viper grinding can be any operation. But for the succeeding process, it can be separated into two parts, which are the succeeding process of grinding wheel and the succeeding process of workpiece. For the grinding wheel, we can apply the dressing and truing process to it. The dressing process is to sharpen the grinding wheel, but it doesn't mean that this process will remain or give the same shape of grinding wheel. So, we have to apply truing process after that to make the shape of the wheel to initial shape. For the workpiece, we have two processes to choose to finish the workpiece. First process is lapping, that produces an extremely accurate and smooth surface of workpiece and also correct minor shape imperfection. The second process is polishing process. This process is an operation to make a rough surface to be a smooth surface by removing scratches and burr of the workpiece.
Compared with other grinding processes, wiper grinding is more efficiency. From this table, clearly both the number of operations and the cycle time of old creep feed process are 4 times more than new wiper process. The old process requires more machine tools and money to produce a part, and throughput time is much more longer than wiper process. A casing that took 10 hours to mill by using old process only need 4 hours to complete by using wiper process. A bearing house using the wiper process can reduce 66% of cycle time, 5 setups, and half of consumable costs. And a compressor blade using wiper process can reduce half of cycle time and overall cost, 80% of consumable costs, and 6 setups. So that wiper grinding can not only save a lot of time and money, but also energy and materials, which means compared with other processes, wiper process is more user and environmental friendly. Makino has been set up in the UK to market the technology throughout Europe, principally within the aerospace and power generation industrial, but also in the motorsport and the medical sectors. The wiper system allows cool grinding with excellent foam holding and profile retention. Cool cutting is particularly important when grinding nickel-based aerospace components, such as turbine blades, rotor blades, and nozzle guide vanes, which are primary application of wiper grinding. And here is a video about Makino G7 grinding machine for aerospace engine components.